Live. All right, we're good to go. Perfect. Hello, everyone. Thank you for having me over. Today we're going to talk about JSON Web Tokens. A lot of people will call them JWT. I like to say that it's not called the JWT, so I'll just start with that. The official specs suggests that you should call them a JWT, but it's still in proposed state, so it's not officially passed. So I am a strong advocate for calling them JWTs and not JWT. It really bugs me. So if there's one thing you should remember from this talk, let's call it JWT. All right, with this in mind, whoever used JSON Web Tokens in the past? Okay, about a few, about half. So today I'll be talking about JSON Web Tokens, what they are. Yesterday I talked pretty much about how to use them in the context of OAuth flows, as well as OpenID Connect. I'll kind of really quickly touch on that today, but really what I'm going to talk about is the JSON Web Token as an actual token, part of the that you can use with OAuth, and what it is and how you can use them. And I'm terribly sorry, I had an accident this morning and I broke one of my teeth, and it's horribly painful, so I'll try to keep the talk like not too long because my mouth goes dry and I cannot drink water because it really hurts. So it's kind of a weird thing that happened this morning. But anyways, let's go. So very quickly, a little bit about me. My name is Joel Lord. You can find me on Twitter with Joel with 2 underscores Lord, which is a horrible Twitter handle, but that's what they had available. Funny story, I realized after a few years that Joel Lord in one word was actually already taken by myself with another email. But it's too late to change it anyways. So if you ever want to get in touch with me, that's always the best way. I get very, very excited whenever I have a Twitter notification or a new follower, so you can be sure that I will answer your messages. I work with Auth0. We're a company that does an identity management platform as a service. So basically, they take care of everything that has to do with the login of your users, and they manage all of that, all of the sensitive information about your users, like their passwords, in a secure way. Very, very easy to use. We've got an SDK, and in the background, we use OAuth and standard protocols, as well as JSON Web Tokens. I work as a technical evangelist for them, which basically means that I get to learn about that stuff a little bit more, and then I go to various conferences and meetups like I'm doing today, and just talk about those technologies so that people can kind of know what it is. Also, I'm French-Canadian, as you might have noticed by the accent. I like to mention it, just in case you were wondering why it's this charming accent, where it comes from. And I currently live in the Toronto area. I'm in Canada. So let's talk about single-page applications and best practices in security. Now, who uses single-page applications? Like React, Angular, Vue? Okay. As you might know already, if you're using or building a single-page application, basically you're building the whole application and you're pushing all of that code to your browser, which is really cool because then all of the application is blazing fast. If a user clicks on a different route, it just hides different sections of your page, shows other sections of the page, and it's really, really fast, as opposed to what we used to do with PHP applications, for example, where you would send a new request every time you needed a page. So much faster, makes some much, much better user experiences. But we're passing all of the information to the user. All of the source code is all available for them. So basically, when you're talking about best practices in security, since you're giving all of this source code to your users, well, your single-page application can never be secure. So that's it. Like I said, I'll keep it short. Thank you very much. All right. Okay, let's just look at a traditional application using PHP. I used to do PHP. For those of you who are here yesterday, you already know that. But I did PHP in the early 2000s, up to about 10 years ago, where I switched to JavaScript. I finally saw the light and went to the good side. Oh, that's going to be painful. Okay, sorry. So when you had a PHP application, you had a server and you had a user, and your user would try to access your page. So it would simply do a request on the browser, and the browser would generate all of the HTML code and send you back a full PHP page or an HTML page. Now, if you needed access to a page that was secure, that had some sensitive data, some protected data, you would do the request. But if you were not logged in, the page would be declined, or the request would be declined. You would either get an error message, or the page would be, or the HTML would be rendered in a way that would say, you are not accessed, or you're not allowed to view this data. So you would pass in your credentials. It would create a session on the server. Server would create a session, and that session would contain a bunch of information like who you are, or are you authenticated or not, what's your name, what's your user ID, and all that stuff. And then it would send you back a cookie. Once you have that cookie, you would pass that cookie with every single request that you made to your PHP server, and that would identify which session that was on the server that mapped to you, and then it would serve you some data based on the user that you are, based on your permissions, and so on. So it's kind of easy to manage all of that because it's all a black box, everything is done there, and the source code that the user actually receives is only the HTML that was generated by the PHP server. So it was really easy to keep all of the sensitive information hidden, and the different routes and all that stuff hidden on the server. But nowadays we use APIs, RESTful APIs, and it makes it a little bit easier for different reasons. Because we're using an API, all of the data is served by the API. We don't generate the HTML on it. We really only serve the data, typically as a JSON object, but it doesn't matter. It could be done as anything. And on the other side, you've got an application. Your application could be a single page application. It could be an Angular, React, Vue. Doesn't really matter. Actually, I'm a JavaScript developer, so I'm very opinionated. It matters. Vue rocks, React is meh, Angular sucks, right? To any Angular users? Oh, sorry. So you can connect using a single page application. You can also connect using native applications, which are not necessarily using the same HTML rendering. Or you could even use conversational UIs. So Google Home or things like that. So it makes it a little bit easier to connect to your API and get that data. So how do we do that? How do we authenticate our users on all of those different platforms so that they can get access to the data? That's where JSON Web Tokens come into play. So JSON Web Tokens, there's an official RFC. It's a standard. It's defined. There's a group of people working on it, doing some silly stuff like calling it a JOT, but also some very, very nice stuff. It's an open industry standard method for representing claims securely between two parties. So essentially what that means is that it's a piece of digital information that can be used to share information between two machines. There's a lot of different tokens that you can use. You can create your own. But in this case, there's a very, very well-defined standard that is called the JSON Web Token, which makes it very, very easy to use. JSON Web Token looks like that. It's a bunch of different characters, and we'll kind of see what this means. But as you can see, it's fairly lightweight. It's not a lot of characters in there. There's not that much information, so it's very easy to carry around. It's also all characters that are URL friendly, so you can pass that as part of your query parameters when you're doing a request on a server or back to your single page application. When I started at Auth0, one of my first tasks that I had to do was to read through all of the spec, which, to be honest, is not the most interesting piece of literature that you can read. So instead of going into the very technical details, I'll try to do a comparison with something that we all know. And I'll compare that to a driver's license. So if you were here yesterday, you already saw that. So, and I like to use this image because I used to live in Quebec. And it's interesting because the driver's license that I had from Quebec was always the piece of ID that I would use anywhere in the world. I would go to any hotel in the state, I would use that as my main piece of identification, and they would always accept this piece of ID. And the reason why that's surprising is that it's all in French. But still, people will respect that as a valid piece of ID. There's a bunch of things in there. There's a lot of information, like what my name is, my date of birth, My picture, there's information about how to prove that this is a valid piece of ID. There's some things that you can scan there. So all of that makes that a valid piece of ID. So we'll see how that compares to a JSON Web Token. So a JSON Web Token has three different parts. It has a header, a payload, and a signature. And obviously, the driver's license kind of have the same things as well. So it has a header, a payload, and a signature. So let's look at them one section at a time. If we look at the header of our driver's license, we can find some information like, well, actually it says that this is a driver's license, even though it's written in French. Tells you who issued this piece of ID, so the government of Quebec, and so on. Now, the JSON Web Token has three different parts. They're separated by dots. So you might not see them, but there's one there, one here. If we extract the header from there, we have something like this. This is a JSON object that was actually base64 encoded. So if you use the A to B function, which is native in your browser, you will get this. So this actually already makes a lot more sense. So we can see here that it says that it's a type JWT. So it identifies itself as being a JSON Web Token.
I have a dumb question. Why base64?
Why base64? The exact why, I don't know. What I do know is that it makes it easy for being URL friendly.
Okay.
There's probably a bunch of different ways to encode it that are also URL friendly. So why that specific one, I'm not sure, but it is.
You can have all sorts of things like new lines in your data, and if you try to put that into an HTTP header, you're into a world of pain. You put it in something rich, you can put it all in one long line. Thanks.
Gotcha.
Thank you. And the other important piece of information that you'll have here is the algorithm that is used to sign our JSON Web Token. The signature is very important, and I'll come back to that. So going back to our driver's license, it also has a payload. That payload has a bunch of different things like the picture, the name, the date of birth, the different restrictions as well. So I'm allowed to drive a car, but not a semi-truck. And in our payload, we've got something similar. So once again, we've got this little piece of code, and we can use the same function once again. And we see that this is a JSON object as well. So very standard formatted JSON object. And there's a bunch of different things in our payload. The payload itself is not defined by the standard, so it could be anything. You can put in whatever you want, but there's a few reserved keywords in there. They actually call those claims. A claim is just a key value pair here. So those that have 3 characters, so sub, ISS, AUD, IAT, EXP, those are reserved claims, or keywords that should only be used in a specific use case. Those are defined as standard. There's about 100 of them. If you're not sure if you're going to use one of those restricted keywords, just use more than 3 characters. So the reserved are always 3 characters long, just to keep it short and make sure that the JSON Web Tokens are as lightweight as possible. But some of those sub is typically, or not typically, it's always the subscriber ID. So who is this token about? What is this information about? It's typically your user ID in your applications. ISS mentions who issued this JSON Web Token. It's very important to know who issued that JSON Web Token so that your API can verify that this JSON Web Token comes from a valid source that is a trusted source. AUD is the audience, so it tells you who is this token meant for. So there's a lot of issuers that, like some services like Google OAuth services, you can use those to generate JSON Web Tokens. But if you generate a JSON Web Token, you have to make sure that the tokens that you will have on your API are meant for that API specifically and not for another one. So AUD identifies the API or the audience of this JSON Web Token. IAT is a timestamp, so the issued at timestamp, and EXP is the expiry timestamp. So JSON Web Tokens have a finite life cycle, so they usually expire anywhere between a few minutes up to a few days. Once again, it's not defined as part of the standard, So you can really play with that. It's up to you and to decide based on the application that you're building on how long you want those to be live. Finally, on our driver's license, we have holograms, we have signature. So there's a bunch of things that prove that this is actually a driver's license. And it's because of those that this is actually accepted anywhere. So in our JSON Web Token, we also have a little string here. And what this is that it's a signature generated by, and it could be, once again, a lot of different algorithms that you can use to generate a signature. But in this case, we're using HMAC 256 for the sake of simplicity. When you're using a function to generate a signature using HMAC 256, you will take some string that you will encode. So you will take the header and the payload in this case. And then you will take a secret key that is shared between the API and the authorization server. And based on that, you will generate a signature. All right. So that signature looks a little bit like this. There's a lot of different algorithms that you can use. If you're using HMAC 256, make sure that you have very long secret keys because they can actually be brute forced. So if you're using something between 4 and 8 characters, it's like, actually at 4 characters, it's very easy to brute force. At 8, it starts to be a little bit more difficult. So you've got to go like all the way to 16 characters to make sure that this is secure. All right, so once you have all of this, you've got, and I'll just take a simple example for the main usage for our driver's license, which is proving your ID when you go to a bar. I live in Toronto now, I don't drive anymore, so. So you've got a government issuer, so you've got a trusted source that will issue those pieces of ID. So you'll typically go in, you'll have to go through a process to generate those. In the case of a driver's license, you just have to fill in a bunch of paperwork, and it will return you a driver's license. So if you go to a bar, there will be a bouncer, so you'll go in there, and the first thing that they will ask is, what's your ID? So you'll give them the piece of ID, and they'll let you in. But if instead of going through the official channels, say you're not 18, or what's the drinking age here? 21. Say you're not 21 and you still want to go to a bar, you know, there are some people apparently, from what I heard, that will generate some pieces of ID in exchange for a little bit of money. But and they will give you back an ID. But if you try to use those, because it will have a bunch of things that will not match, if they try to pass it through a UV light, they probably won't see the holograms. There's a bunch of different things that they can actually check. And if it doesn't work, then you'll be rejected the entrance to the bar. So that's why you need a strong signature and a strong way to validate that this is a valid piece of ID. All right, let me just show you a quick demo of a JSON Web Token. So JWT.io is a very nice site that you can use if you need to play with JSON Web Tokens and you need to debug your way. If you have some information coming from an authentication server and you have an API and you're trying to figure out why that JSON Web Token is not accepted by your API. As you can see.
You said JWT.io?
Yes. We'll be on the screen in a minute. All right, JWT.io, very, very useful. Wow, that is bright. Very, very useful to debug anything that has to do with JSON Web Tokens. So if you paste in a JSON Web Token in here, on the right side, you can see all of the decoded information. As you can see, all of that information was right there in my JSON Web Token, and it's not encrypted by any way. So it's very important that the information that you will put in the payload, although you can put anything that you want, make sure that there's no sensitive information in there, because then it could be easily readable. This is actually the example that I wanted. So as you can see here, I have my payload, and I have a user. It has a user ID 1, 2, 3, 4, 5, 6, 7, 8, 9. The name of the user is Mr. Cat. And scope is the claim that is typically used for permissions. So it tells you what this user is unable to do. So Mr. Cat has the right to be cute. All right. But say Mr. Cat is a hacker, and he wants to have more permissions on the API. So what we can do here, is that big enough?
Make it a little bigger.
I'll make it bigger. All right. All right, I'll take my really? I'll take my JSON Web Token here and I'll store it in a variable. Okay, so there it is. And I'll split all the 3 different parts because I want to change the payload in there. Oh, not that one. Why? Just give me a second. Okay, sorry about that. Okay, so I have my JSON Web Token with an invalid signature. Okay, so now it's there. So now I'll split it, and like I said, there's 3 different parts to it, and they're all separated by a space. So if you want each of the parts, you can do parts equals split. There you go. And now my payload is that part in the middle. So payload looks like this. So I only have the middle part of it. So now I can take my payload and run the A to B function on it. So as you can see, it starts to look like a JSON object. I just need to JSON parse. Right, and I have a JSON object. So now I can see all of the information that was part of my JSON Web Token. So let's say that Mr. Cat wants to add new permissions. Scope, not push. And he wants the right to push things off of the table because it's a cat. All right, so now I've got my payload. It now has my 2 permissions. So I'll just re-encode everything and put back my JSON Web Token together. And right, and then I'll use B to A to convert it back. All right, so now I have my new payload, and if I just inject back into my JSON Web Tokens, and I recreate my JWT. All right, so now in theory, I have a JSON Web Token. I've been able to hack my way into it, and I've added new permissions to it. So I can just take this, copy it back into this here. As you can see, it's a little bit longer. It now has the permissions of scope, and the Mr. Cat is now allowed to push things off the table. So that kind of shows you that it's not very secure, but is it? Haha! So if I scroll down, I can see that the signature is invalid now. So that's because when I did this signature, I was using both the payload and the header to generate this string based on some fancy maths there. So if I change the payload, the application here will be able to detect that the payload has been tampered with. So that's how JSON Web Token are still kind of a secure way to pass information. Because it's signed, you can verify that it's valid. But if you're using JSON Web Tokens, make sure that you validate that the signature is still valid. That is one of the most common mistakes that you can see on authentication servers or APIs, is that APIs will not verify the signature. So anyone can just tamper with, add new rights, new permissions, and then they can have access to some of the most sensitive data in your system. So that's a very important part when you're playing with JSON Web Tokens.
Good question. Why does the header also get included in the signature?
Because you could also tamper with the header. In this case, there was no real information apart from the fact that it identified it as a JSON Web Token and the algorithm. But you could put in some more information like, some APIs will require, I was playing with the ABLI API, which is a real-time communication API. And they require JSON Web Token that have very specific information in the header of the JSON Web Token to identify this being an ABLI token or JSON Web Token. So in this case, you want to make sure that if I change anything in there, so I was using a JSON Web Token from auth0, I would change the headers as well as the payload, and then I would generate a new signature to make sure to send that to the ABLI servers. So you also need to check the header.
Okay, so the spec also includes like what can be part of the header in the JWT?
Once again, the spec is very loose as to what goes into the JSON Web Token, so you can put whatever you want in the header. But there are a few restricted keywords in there.
Okay.
All right. So we now have this. Let me just change back again. All right, so now that we have this structure, we have our JSON Web Tokens. If we need to access some sensitive data on our API or a protected route on our API, we can try to access it, but without a JSON Web Token, we would typically get a 401. So you would check and ensure that there is a JSON Web Token present in the request when you're trying to access data on your API. And if there's not, or if the signature has been tampered with, or if the user doesn't have the right permissions, you would return an error message. So in order to have this JSON Web Token, we will need an extra part. So we'll still have our API, we'll still have our application in the middle, but now we'll need an authorization server or some sort of authority that will generate JSON Web Tokens for us. Typically in the OAuth world, what this would look like is that you would have an authorized endpoint on your authorization server, and the authorization server would take care of validating the identity of the user. This would typically be done using a username and password, but it could be done using passwordless. It could be done, you can add multi-factor there. There's a bunch of different things that you can do to validate the identity of the user. But once it's validated, you simply return your JSON Web Token to your application. Once you have that JSON Web Token, then you will pass it along with your request. So you'll pass it as part of your headers to your API. And once you have that information, the API will give you access to the resource and actually serve you the data that you requested. So if you need to send this data over to the API, and really I'm focusing on the front end, I should have mentioned that at the beginning. But I'm focusing on the front end here. I won't look at the details on how to validate the API or the JSON Web Tokens on the API. If you're interested by that, you can listen to yesterday's talk, which is available on codeandsupply.co/media or videos. We're not sure. Or click on the big media button. If you're using Axios, a very, very useful package to do AJAX requests in a Promise environment. You can use axios.post or whatever it is that you're trying to do, and you simply add your headers. You'll add an authorization header. You'll say bearer because it's a bearer token, and you simply pass the token as part of the header. So it's very, very simple to add. Very simple to add to all of your requests, and you can just add, just add those to all of your outgoing requests. If you're using the fetch command, which is now part of most browsers, pretty much the same thing. You simply add a new header. You say authorization, bearer token, same thing. Basically, it doesn't matter how you're doing your AJAX request. The important part is that you have this authorization header as part of all your outgoing requests on your API. A question that I get a lot of the time, because JSON Web Tokens are very sensitive, if somebody gets a hold of a JSON Web Token, he can actually impersonate your users. So you have to be really careful what you do with your JSON Web Token. And that's a very important responsibility that you have as a developer, especially in the context of a single page application where all of the information is there. You want to store that somewhere. Originally, people said store it in a cookie. That works, but then it was open to various vulnerabilities like the CSRF, I think, was the vulnerability there. Anyways, it's dangerous to store it in a cookie. So then people started saying, well, put it in a local storage. Local storage is safe. It's only accessible by JavaScript, only by your application. But then, because we run npm install all the time, and it installs a gazillion different JavaScript libraries, and nobody actually goes through their node modules directory to verify that all of the files there are actually secure, then local storage is always potentially exposed to one of a vulnerability in there. So the best way to do it is always to keep it in memory. It's the hardest way to actually access it. Unless you really know the variable name and you go into the console, maybe you'd be able to. But since our code is typically minified, trying to guess that, it gets harder. It's not the best way. It's kind of security by obfuscation, but it's pretty much the best way that we have so far to keep the JSON Web Token. But it really sucks because if the user refreshes the page, he has to log in again. So that's the downside to it, because when you refresh, you're losing all of the data in memory, so you have to re-authenticate your users. If you're using Auth0 as a platform, as an SDK to help you with the JSON Web Token management, what we do here in this case, and that's not defined by the standard, but that's the workaround that we found in order to help and to encourage users or developers to store the JSON Web Token in memory, is that we keep a session open on the authentication server here. So it will send you a JSON Web Token, but it will also send you a cookie. Now the cookie will be stored with the other cookies in your single page application, and you will keep the JSON Web Token in memory. But if the user refreshes the page, what happens in the background is that we create an iframe and we create a connection to the authentication through an iframe. And that connection will actually use the cookie in there to verify if there's a valid session on the authentication server. And if there is one, a new JSON Web Token will be provided, and then you can store that in memory once again. So that's not part of the standard, but it's the way that we found at Auth0 to kind of help with that. Now, if you need to secure your single page application, like I said, you can never really secure any of the routes. Because all of the code is there, you can just do an inspect element and show and hide different elements. So if you have a button that is just hidden from the user with a if user equal admin, it's very easy to actually go in there and just show the button. So you can always have access to all of the stuff that is in the UI that is meant to all of the users. But you can at least hide some of the different routes. So if a user tries to access, your page / secret area, there are ways to kind of not give them access to it. They will still be able to go into inspect element and to actually see that data. So that's why you need to make sure that your API is protected and not serving any data using that JSON Web Token. But if you want to hide different sections of your user, it's always possible. So single page applications, just as a refresher, for those of you who don't build one, basically you build one big application and you have a bunch of different divs, and each one of those divs will be like one page on your single page application. So what you'll do every time that a user changes route and goes to another page, you will hide everything and you will just show the section that he actually wants to see. So that's why it's really fast. Everything is there, but we just show it or hide the different sections. So if you're using plain vanilla JavaScript, a very basic router looks a little bit like this. So you have all of your different routes that are defined there. So you've got the home page, which is public, and then you have a secret page, which is not public, which you hide, and you will only give access to your authenticated users. You'll use the event listener for hash change. So whenever the hash part of your URL changes, you will check the route that was part of the hash. You will check if the user is logged in. Depending on what you're using in the background, you can use multiple things here. And then you'll hide everything. You'll hide all of the different sections on your page. And then you'll check if the page that the user is requesting is public, then you can display it. And if the page is not public, but the user is logged in, you can also display it. Or if not, you just show a page that says unauthorized. That's pretty much how it works. If you're using Vue, it's very, very simple to actually do that as part of Vue. You have a before enter callback in each one of your routes that you can define. And in this case, I'm just referring to this function here. So I simply check, is the user authenticated? If he is, then show the page that he's requesting. And if he's not, just show an unauthorized page. If you're using React, it's also relatively simple. You can create a component private route if you're using React DOM router. And your private route will do pretty much the same thing as we've just seen in Vue. So you'll verify if the user is logged in. If he's not, you just redirect them to an unauthorized page. If you're an Angular developer, I don't know. I've heard that it's easy, but I really didn't bother to take a look. Right, so just a few general resources. If you're interested in JSON Web Tokens, JWT.io, very, very good website. A lot of information there. There's a lot of different libraries that you can use to encode and decode JSON Web Tokens as well. So you can take a look. I talked very quickly about different signing algorithms. So I showed HMAC256 as part of my examples. RS256 is the most secure one that you should be using, but if you're interested about those, you can take a look. And if you're really into JSON Web Tokens, there's a very good JSON Web Token book that is available for download for free, which you can take a look at. So single page application security is mainly concerned with authorization. It's mainly on the, and many has to be done on the API side. So you have to make sure that your API validates that the user is actually connected. But you can still use JSON Web Tokens for securing single page application. And when I say secure, I'm using air quotes because it's not really secure. A user will always be able to show and hide the different sections in your web page, in your single page application, but you can still kind of hide some of the different routes. So it makes it for an experience that is a little bit better for your users. And there's a lot of different libraries that are available. So if you have to play with JSON Web Tokens, please use one of those libraries. There's a lot of pitfalls if you're trying to encode or decode them, and you have to make sure that it's done in the best way possible. So you can use any of those libraries that are actually all valid and they all work and they're all done for you. So please use those if you're gonna play with that. That's all I had, so thank you very much. I'll take one or two questions, maybe. Yes?
What is the best practice for storing the secret key? Because I know you mentioned keep it in memory.
Where do you store the secret key? That's a very good question. So the secret key should never, ever, ever, ever be in the front end. If you have the secret key, if Mr. Cat had the secret key when I showed you how to hack the JSON Web Token, then he would have been able to generate a new signature and he would have generated a valid JSON Web Token. The secret key has to be kept a secret. So you keep it on the authorization server and you keep it on your API. You never, never, never put any of that information in the front end.
So that question, and so both of the authorization server and the subject server, they have to communicate because they have to have that key.
No, you can hard code them if you're using a secret key.
Right.
If you don't want to use secret keys, then you can use private public key pairs.
Right.
And then they are shared publicly because it's a public key. I'm really not familiar with that concept. It's part of my holiday reading. It's going to be super fun. But that's the easiest way to do is to have public-private key pairs and to share those and use those. So those are and they can easily be changed every now and then. So it's either shared secret on both ends or private-public. Yes. So but they both have to be in cahoots somehow because the middle guy doesn't know anything. He's just passing through. Exactly. Okay. Exactly. Any other questions? Very good. Well, I'll stick around for a few minutes anyways. So if you have any questions, feel free to come and talk to me. And I also left like a bunch of Auth0 stickers all over the place if you want, so feel free to take some. And just feel free to contact me if you have any questions. Thank you.
Thank you.